Hi everyone, so in this video we will talk about section 5.5, which is the substitution, or some people, some textbook also call it U substitution. Okay, so what the U substitution will work. So let's take a look at the idea of that first. So the U substitution will work for chain rule. So we have chain rule in the derivative. So chain rule, if we have the function f some other function, then when we take the derivative of this composite function, we're gonna have to take the derivative of the function outside times the derivative of the inside function. Okay, so we're gonna take the function outside times the derivative of inside function. For example, if we want to take the derivative of sine 2x squared per 2, then what we're gonna have to do, we're gonna have to take the integral of sine, which is cosine. Everything stay the same. Times the derivative of the inside, which is 4x, right? Which is 4x. Okay, so the derivative of the outside function, which is sine x, and the derivative of inside function, which is 4x. So cosine 2x squared per 2 times 4x. So this is the chain rule for derivative. So now that let's say we want to do reverse. So we want to take the inverse of that. So we're gonna want to take the integral of this to get back our original function. So we're gonna take the integral of f prime of g of x, g prime of x dx. Okay, so how do we gonna check the integral on this? So we're gonna do the same thing. We will call u is g of x. So u is g of x. So when we call u is g of x, isn't that we can take the derivative both sides with respect to x. So I can do du over dx is equal g prime of x. Okay, and du over dx, I can multiply both sides by dx. That will give me du equal g prime of x dx. So that's why when you see some of the U substitution, you will see they jump from this step to this step. So you're gonna let u be the function that when you take the derivative will give you g prime of x dx. Okay, so that's going to be your du. So du is g prime of x dx. When we put that into, we're going to replace that back into the integral. We will have integral of f prime of u. The whole thing of this will become du. And the integral of the derivative are the inverse of each other. When you take the integral of the derivative, this will give you back the function fu. And then plus c. But your u is g of x, then that's going to be f of g of x plus c. Okay, so look, when you take the derivative of the composite function, you got this f prime of g of x times g prime. If you take the integral of f prime of g of x times g prime by using u substitution, let u be the inside function, you will come out with the original function. Okay, so this is going to be called the u substitution. Now let's take a look at this example. So when do we know what is our u base? Our u will be usually be the function inside of the other, right? So for example, this one, the inside of parenthesis function will be x squared plus 1. And you think about it, when we take the integral of the derivative of x squared plus 1, we will get something outside. Okay, so let's see the problem first. Let me change this problem to a simple one first, and then we're gonna go more at. Okay, now let's using u sub. So we're gonna have our u. This is our function f. Okay, so our f of g of x is equal to x squared plus 10, plus 1 to the power 10. Right? So the inside function, the g of x, the input of that function is x squared plus 1. So we're going to let u equal x squared plus 1. Then our du will be what? Du will be the derivative. We're going to take the derivative normally. Our du will be 2x dx. 2x dx. So look, when you let your u to be something, you take the derivative of u. It should equal to the remaining function, right? So it's going to be 2x dx. That's going to be du. So when we substitute everything back to the integral, we will have, instead of x squared plus 1 to the power 10, we're going to have u to the power 10. And then instead of 2x dx, we're going to have du. And that will give us the integral to be something easier to check the integration, the antiderivative, right? What is the antiderivative of u to the power 10? We're going to look at the power rule, right? We're going to have xn plus 1 over n plus 1 plus c. Then u will be the same thing. They just a different variable. They just, instead of x, you have u. So it's going to be u to the power 10 plus 1, which is 11, right? Over 11 plus c. But we don't leave our answer like this because our problem have the variable is x. U is just the variable that we use to make the integral easier to integrate. So we're going to have to replace back our u to x squared plus 1. So we have x squared plus 1 to the power 11 over 1, 11 plus c. Okay, so this is going to be the antiderivative of x squared plus 1 to the power 10 times 2x. If you go ahead and take the derivative of this function, you will get back the original one. Okay, so because they are the inverse of each other. And this is how you use up. We're going to see more example in the next video.